In the previous video, we have already discussed about perceptron, and also we have discussed how it works and whether we can use it for some regression problem or classification problem or not. Now let's go and check what is a neural network, or we can even call it as artificial neural network as well. So we'll see what this is and how these guys or how the scientists build this particular neural networks. All these things we will be going through in this particular video. Basically, as I said, scientists want to build something similar to human brain, right? So that's why they started studying about the biological neuron. And once they studied enough about the biological neuron, and they came up with this particular mathematical structure of neuron, that is perceptron. And how it is done and all that we have discussed in the last video. If you have missed out, please check it out. Now let's go and see. So basically, here the main idea is to implement brain, right? Implement brain mathematically. So in order to do that, first let's try to understand how the brain connects all the neurons that it has. So basically, let's say each circle is some neuron. Okay, each circle that we see is a neuron, let's say. Then all these neurons will be connected to one another in some order. Okay, so like there is no proper order because brain is very complex structure. It can happen that any neuron can get connected to any other neuron. So like that, all these neurons will get interconnected. For now, I'm just showing very few neurons, but our brain is made up of some billions and trillions of neurons. So by inspiring from this specific structure, we have, or these scientists came up with this specific neural network. So for this neural network, first we'll be having the input layer, that is x1, x2, x3, so on, xn. Basically, this input layer will contain our input features information. Like, let me first draw this. This is our input layer. So in this input layer, we'll be having the data set, right? So we have seen what is a data set and how it will be looking like. So in a data set, we'll be having feature 1, and also we'll be having feature 2, and we'll also be having feature 3. Like that, we might have so many number of features. Like let's say we are having n features, and for all of these n features, there will be some corresponding output y, right? So this will be my data set, and in this data set, there can be one data point which might look something like this, that is x1, x2, x3, so on, xn. And finally, for this particular input data, that is x1, x2, x3, so on, xn, we'll be having the corresponding output, that is yn, right? So this, my data will look something like this. So these points I'll be sending as input in the input layer. So let's say my input is x1, x2, x3, so on, xn. Then this point will be sent as input in the input layer, and then we'll be having something called as hidden layers. So this hidden layers, it contains nothing but neurons. So what are these neurons? These neurons or perceptrons, we can say. So those will be present in the hidden layer. So let me write completely hidden layer. So this we can call it as hidden layer 1. Like that, there can be as many number of hidden layers that we wanted. There is no specific restriction that you need to have only this many number of hidden layers. It is up to you. You can use as many number of hidden layers as possible. So this can be something like hidden layer 2, and like that you can have n number of hidden layers, or as we have already used like n over here, let's use the number of hidden layers to be m. Like that, we can have m number of hidden layers. And finally, you can have something like output layer. So in the output layer also, we'll be having the neurons itself. We'll be having some number of neurons, and finally through this we'll be getting the output, that is y cap. And in perceptron, if you guys remembered, in perceptron or normal neuron, what happens? Basically, all the inputs that we have, like x1, x2, x3, so on, xn, all these inputs will get connected to the neuron, right? So if this is perceptron or neuron, all my inputs will get connected to this. And on all of these connections, there will be some weights, right? So similarly, here also we'll be having some weights like W1, W2, W3, W4, so on Wn. So these are the weights on these connections. And similarly, these are only the connections, if you carefully observe, these are only the connections that are made from these inputs to the neuron or to the first neuron in the hidden layer. But there are so many other neurons also, right? So for all these neurons, we'll be connecting my input x1 to all the neurons. And similarly, my x2 is also connected to all the neurons. And similarly, x3 is also connected to all the neurons, and similarly xn is also connected to all the neurons. So like that, we'll be connecting all the like inputs that we have in input layer. All those will get connected to like neurons in the hidden layer. So each and every neuron will connect all the inputs. Once we connect like this, in perceptron we have already observed that on each connection we will be having some weight, right, which is similar to thickness in case of like biological neuron. Similarly, here also, in order to show the importance of the input or through what kind of connection that we are sending in case of biological neuron, so in order to show that, here we will be having weights, okay, and each of these connections will carry one weight. So if you carefully observe, there are n number of neurons over here, or n number of inputs over here, sorry, n inputs. And in case of hidden layer, let's say we are having 5 total. If we observe over here, there are 5 neurons in this case. So total, what is the number of connections between these two? There will be total n into 5 number of connections. And in the previous video, we have already discussed that for one perceptron, there will be one bias term. So here, if you observe in the input layer, like these are all not neurons, right? These are just inputs. So we'll not be having any bias terms. But whereas in case of hidden layer, all these things that we are seeing over here, these are neurons, right? So as we discussed, for each neuron, we'll be having one bias term, right? So this one will be having one bias term, 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 this one will be having one bias term. Like that combinedly, like this will be the total number of weights on connections, and plus we'll be having 5 more bias terms, each for the neurons that we are seeing over here. So like that, we'll be getting the total number of weights in between the input layer and hidden layer 1. And similarly, after passing all of these inputs to the neurons in hidden layer 1, this will be giving one output, that is O1, and this will be giving another output, that is O2, and this will be giving another output, that is O3, this will be giving another output, that is O4, this will be giving another output, O5. Like how we send this x1, x2, x3, so on, xn to the hidden layer, in the same manner we'll be sending all these 5 like outputs that we got from this hidden layer. These will be sent to the next layer in the same manner how we sent this x1, x2, x3, so on, xn. That means O1 will get connected to all the neurons in hidden layer 2, and similarly O2 will get connected to all the neurons in hidden layer 2, and similarly O3 will get connected to all the neurons in the hidden layer 2. Like that, all the neurons that we have in hidden layer 1, or all the outputs that we get from hidden layer 1, all those will get interconnected with the neurons that we have in hidden layer 2. Like that, the same thing will happen here also. We'll be having how many number of weights? Let's say here also there are 5, and here also there are 5. Total, it will be 5 into 5 number of connections. So this represents the weights on connections, and also we'll be having extra 5 weights. Those are the bias terms. Okay, so this will be the total number of weights in case of hidden layer 1 and hidden layer 2. Like that, so on, we can have as many layers as possible. And finally, in the output layer, we can have, let's say, for suppose we are having one neuron. So all these, let's say here, total number of like neurons in this particular hidden layer is, for suppose, m. Then total number of, what will be the total number of weights between these two layers? It will be m. So here there are m, whereas here there is only 1. So it will be m into 1 number of weights on connections, plus we'll be having extra 1 bias term. Okay, so for this specific neuron, and The bias terms for these neurons will be calculated in or will be counted in the previous layer itself. Okay. So I hope you got some clear idea how can we calculate the weights in each layer. Okay. So overall, this thing that we are seeing over here, this will be the neural network, or we can say artificial neural network. So I hope this is very clear for you. In the next video, we'll see like what all changes that we make and what are the parameters, what are hyperparameters, and mainly what kind of problems can we solve with this particular neural network. All these things we'll be seeing in the next video. I hope the architecture of the neural network is very clear in this particular video. So see you in the next video. Thank you everyone. Bye bye.